Hey guys, buckle up. This is going to be crazy, but this is gravimetric analysis. I'm going to be introducing it in a conceptual way. Now, imagine chips, a 100-gram bag of chips. And I'm curious, how much salt is in these chips? NaCl. Now, gravimetric analysis will enable me to figure that out and answer my burning desire by taking this sample, dissolving it in water, which is a common method for gravimetric analysis, and then filtering that water and collecting the solids that are weighed. The formal definition for gravimetric analysis is a quantitative determination of an analyte based on the base of mass of the solid. So relating that back to my problem, I have the chips and I'm dissolving them in the water, as you see I'm writing, and I have this 100% NaCl aqueous solution, which implies that there's still water in there. So I can't measure that because water weighs something in and of itself. So I'm going to take that aqueous solution from the chips, and I am going to find something that reacts with that salt and produces a solid precipitate, so that I can use that to weigh, actually physically weigh, and determine through stoichiometry how much of this salt is in the chips. So I have this AgNO3 that was given to me by a person who did this experiment previously, and those reactants produce the NaNO3, which is aqueous, and then that solid AgCl. I'm sorry I messed that up. I guess I missed that. And so I have this definite mass, this 1 gram mass, which is another made up number. I made up 100 grams, made up 2 gram sample. So 100 grams. So then you can take that mass and you can turn it into moles, and you can use that with the magical power of stoichiometry. You can go backwards and determine how much salt is in those chips. Here's a more math-based, more realistic question with the use of actual compounds. You have the silver-copper alloy, and you're trying to get the silver isolated. So with gravimetric analysis, is no problem. You have all these aqueous solutions. You use the nitric acid to turn this silver-copper alloy into silver nitrate, copper nitrate, nitrogen monoxide, and that other acidic solution. And what's unique about silver nitrate is that it precipitates on contact with chloride. So these silver chloride particulates are just waiting for you to filter them. So you filtrate them, and then you place them in an oven, warm it, get rid of the aqueous part of aqueous, and turn it into more of a solid form, which you can then measure. You can actually measure and weigh and have there physically, so that you can do mathematical calculations, namely stoichiometry, to figure out what percent of silver by mass is in this alloy. So here in this section we'll be dealing with math. Yes, I know math, it's surprising. Stoichiometry. To deal with the grams of two different compounds, you have to use moles as a middleman in this case. So you take the grams, the 0.1375 grams of silver chloride that you got from the previous experiment, and you put the molar mass on the bottom, and then the 1 mole, and then you have the 1 mole fraction, which in this case implies that the silver nitrate from that nitric acid alloy reaction completely reacted with the chloride, which is not very likely that it completely did. It most likely reacted with a lot of it, but in this case we'll assume that it did react 100% for number purposes and just ease of concepts. And so you end up with that 0.1035 grams of silver. Now this is a little more than self-explanatory. you take the mass of the silver and you do it over the mass of the alloy to get that percentage. Pretty simple stuff. And then don't forget to multiply by 100 so you get the percentage that you need. And so you set it up 0.1035 grams of silver over the 0.1264 grams of the alloy. And when you plug and chug the numbers out, you end up with 81.88%, which is the percent of silver in the alloy. And that's how you do gravimetric analysis in a nutshell. Hopefully you had as much fun watching this as I did writing it out for you. Have a good day.